Guys, today inshallah we're again continuing what we started last time. In the last session we started talking about the chemical reaction of organic compounds, and we said that organic compounds they have certain pattern of chemical reaction regarding to their structure or what kind of bonds they have or what kind of functional groups they contain in their structure. And we said this reaction could be classified into certain types. First kind we explained was substitution reaction, and we said substitution simply means replacing. So in this reaction, an element will replace another element in a compound, an organic compound. For example, said that halogens could replace hydrogen atoms in the alkanes to form halide alkyl, okay, or to form the RX. We said that the active halogen could replace the less active halogen, so fluorine could replace chlorine, but the opposite cannot happen because chlorine is less reactive than fluorine. Then we passed to another type of reaction with addition reaction, and we said addition reaction is the reaction that happened to the unsaturated molecules or unsaturated organic compounds. That mean the compounds which contain double covalent bond or triple covalent bond. So their bond, these bonds could be broken and be saturated by adding different elements. Okay, like for example, we said that the alkene and the alkyne they contain double and triple covalent bonds. They could be broken and added more hydrogen, so they turn to be saturated compounds, like the reaction of hydrogenation. Okay, in which the oils okay are oils, of course, as you can see, they contain double bond, so they could be hydrogenated in presence of catalyst to form okay alkane or saturated hydrocarbon, that which make oils turn to be better and fats and so on. So also we said that this kind of addition reaction could include adding halogens, adding some metals, okay, and so on. So whatever we could break the double bond or the triple bond, and then we add other elements to the carbons, okay, instead of these bonds. Now we're gonna pass to the new type of reaction, which is condensation reaction. So what the meaning of condensation reaction? Actually, condensation reaction it's a reaction in which two molecules they are gonna combine together. Okay, that means we are gonna just make two different molecules. Okay, they attach to each other, and that's always include removing of water. For example, here we have two amino acids. As you can see, we know the amino acid is one of the organic compound molecules that contain two functional group, the carboxyl group COOH and the amine group NH2. So in this kind of reaction here, as okay, that's the carboxyl group and that's the amine group. Okay, so that's why we put amino acid. Each amino acid contains the acidic carboxyl group and the amine group. So here, once we have two amino acids, these two amino acids, maybe they are the same, maybe they are different, whatever. Okay, this R represent that mean we have alkyl group, whatever the sequence of carbon, how many carbons here, that's not the problem. The idea that the reaction already happened in these two functional groups. What happened in that reaction? We said that always this reaction involves removal of water. So as you can see here, guys, okay, the OH and the hydroxyl group is gonna be removed with the hydrogen of the amine group, and that will produce water molecule that is going to be removed out. In that case, you're going to find this nitrogen lack for a bond instead of the methyl hydrogen, and this carbon is still lack for a bond instead of this methyl hydroxide group. So they're going to attach to each other, forming this bond. Okay, so this is a peptide bond. Okay, that the bond which is formed between the amino group and the carboxyl group between amino acids. And like this, we start to build a long chain of polypeptide, which consider the first step of building protein from amino acids. So this kind of reaction we call condensation reaction. This condensation reaction could be in different forms, not just must for amino acids. For example, if we have alcohol like this one, CH3, CH2OH, that is alcohol, and this alcohol will react with acid, for example, like CH3, okay, CO, okay, OH. So in that case here we have that as acid because it contains the carboxyl group, and that it's alcohol because it contains hydroxide group. Okay, so here a kind of condensation reaction could happen because we're gonna find that the OH of the alcohol, okay, or sorry, the hydrogen of the alcohol could be okay removed with the OH of the hydroxide group. So like this water will be removed, and you can find that the rest will bond to each other. So this CH3 still the same, this CH2 still the same, but it miss a bond, and this oxygen also miss a bond, so they will bond with this oxygen, and in that case, okay, you're gonna find it will form this. So here, like this, guys, we have an ester because the ester that is has the okay function group CCCOO. So like this reaction considered as a condensation reaction because we have two organic compounds, alcohol and acid. They are just bonded together to form a new chemical compound, which is the ester. So condensation reaction again, it's a reaction in which two molecules or two organic molecules they are going to bind together by removing a molecule of water, or always associated by removing a molecule of water. You know, our question here, guys, if there anything is not clear for this type of reaction, guys, is it clear?
Yes, Mr.
Okay. So like this, okay, that was the third type of a reaction that could happen between organic compounds. Then pass to the fourth one, okay, which is elimination reaction. Actually, elimination reaction somehow it considered to be like the opposite of the addition reaction. So the idea of elimination reaction that if we put an organic compound in certain conditions that we may be able to remove some atoms of this compound, and of course removing atom will lead to formation of double or triple bond. That means we are gonna convert it from saturated organic compound to unsaturated organic compound. So here like this in the elimination reaction, it's a reaction in which a simple molecule, okay, like water could be or ammonia maybe removed, or that mean be eliminated from the organic compound or larger compound. Let's take an example here. For example, that ethanol, as you can see, that is alcohol because it contains the hydroxide group OH. So it is here a simple alcohol. Once we put alcohol in with a high concentrated sulfuric acid, actually highly concentrated sulfuric acid considered as a dehydration factor. That means this has a high concentrated sulfuric acid is able to okay absorb water. So in that case, okay, or in this situation, okay, the hydroxide group and the other hydrogen carried on the other carbon, they are going to be removed as water, and in that case each one of these two carbons will lack for a bond, so they are bonded together by a double bond. So like this, it's changed from saturated organic compound into unsaturated organic compound. The ethanol changed to be ethene. So like this here, we call this as a kind of elimination reaction. So here, that's like as you can see here, that is kind or this kind of reaction actually the opposite, because if we get the ethene here and we start to give it, or if we just could react with this ethene with hydrogen, it will break the bond and turn to be ethane, okay, which is a saturated hydrocarbon. So elimination reaction somehow is the opposite of uh, addition reaction. So here also, as you can see in this figure, for example, this one of the most tricks, okay, which is done some as a kind of magic of chemistry, okay, as you can see this reaction, just few powder, once we drop it to it some liquid, it turns to make, okay, something that looks like foam comes out from the beaker. So always people ask what that kind of reaction, what happens. Actually, the white powder here, it's saccharose, okay, it's one of the monosaccharide. That means organic compound like glucose, for example, okay. So then we start to add saccharose. That's actually the sugar which we use at home. So if you get some sugar at home, okay, and just you start to smash them in the blender, so they turn to be a powder like that. Then we start to add drops of sulfuric acid, high concentrated sulfuric acid. This sulfuric acid actually will make or start to make the dehydration reaction. It will just absorb most of the water. That means this saccharose, which contain a lot of hydrogen and hydroxide group in its structure, this oxygen and this hydroxide and the hydrogen groups will be removed as water, and finally the saccharose will turn to be another compound which is mainly made of carbon, because most of the hydrogen and the OH carried on this saccharose are removed in form of water, okay, because as we know the empirical formula of saccharose is, let's see here, okay, we said that saccharose is C6, okay, it's C12 H22, okay, O11, it's disaccharide, okay, not monosaccharide, sorry, it's disaccharide. So saccharose here, as you can see, 12 carbons that they carry, okay, 22 hydrogen and 11 oxygen, which means once we add this sulfuric acid, it's able approximately to create about 11 molecule or to absorb 11 molecule of water and leaving 12 carbon atoms. So, or some carbon atom or carbon atoms with some hydrogen, which make this black substance. So this black substance actually is carbon or mainly made of carbon. That's example of the dehydration reaction or elimination reaction. Is it clear, guys? Here, guys, is that clear?
Yes.
Okay. So here we pass to the fifth type or fifth reaction, which we will consider to be a very important reaction that we use it in our daily life and it used in a lot of industries and so on, which is the polymerization reaction. So first of all, we need to know what is polymer. So as we studied last year in the macromolecules in the biology course, that polymers, they are big or massive molecules are made of small repeated units. Okay, we call them monomers. So monomers are small compounds that are going to attach to each other to build a polymer. So the polymer may be made of the same repeated monomers. That means could be the same monomer. Okay, like once glucose attached to each other, they are going to create starch, for example. Okay, or it may made of different monomers. Okay, like for example, when we have glucose with galactose and fructose, okay, they are combined, they may create a different polysaccharide. So like this here, guys, okay, we have two types of polymer, okay, a polymer that just made of one kind of monomer or a polymer that has different monomers, okay. So like protein, for example, protein is made of amino acids. These amino acids, of course, are different. We have different 20 amino acids. Once these different amino acids are attached to each other in different order, they are going to create a polymer which is a protein. This polymer is, we call it copolymer. Why copolymer? Because it's made of different monomers. While, for example, starch is considered as a simple polymer or a polymer, not copolymer. Why? Because it's just made of one monomer or one type of monomer, which is glucose only. So actually, in our daily life, we already deal with a lot of polymers, or we depend on a lot of polymers in our daily life. For example, the pajama which you are wearing right now or the t-shirt or something with actually most of them they are made of synthetic fibers. These synthetic fibers, they are polymers, okay. The plastic cup or plastic dish or whatever that you use in your getting your meal or breakfast, also they are made of polymerization reaction or they are polymers, okay. The starch, okay, which you eat in your meals, the protein, okay, and so on, they are also polymers, okay. So the polymers actually they are large or huge number of compounds that are found in our daily life. Polymers could be classified in different categories regarding to their reactions or how they already or this kind of polymerization happen. So the first thing here we have something called the additional polymer. So as we could took addition, so that means we remember the addition reaction. So it must include double or triple covalent bond. So addition polymer, okay, that is a kind of polymer formed by adding or adding monomers together. These monomers contain double bond. Like for example, here regarding to this equation, as you can see, we have ethene. Okay, ethene is the simplest alkene that we have, just two carbons. They are bonded together by double bond. So if we have many of this ethene and represent whatever the number is, that means just more than one. Okay, so 2, 3, 400,000, whatever of this is seen. Okay, once we put it in presence of catalyst like the hot surface of nickel, okay, they could combine together, okay, to make a polyethene. As you can see here in the polyethene, this double bond is broken. Why it's broken? Because we just are gonna add another C2H2, okay, to the end of this. So we're gonna build a huge chain that is made of repeated units of ethene. So that's why we put it between bracket and right, and that means this can be repeated for many times. Is it clear, guys, or you need to explain more this part? Is that clear, guys? Is that clear? So again, one more time here. That means, for example, or to clarify the idea, we have this ethene which is CH2, that means it's C, already bonded with two hydrogen, and here there is two double bond and another H2. Okay, sorry, this one is not found. Okay, so we're gonna just bond it with another ethene like it, okay? So what would happen in that situation? In this situation, in presence of catalyst, this bond is going to be broken. Okay, so as this bond is going to be broken, and this bond also is going to be broken, so they are going to attach to each other like this. So this bond is broken right now, and like that. Okay, so then we are gonna have mes2 here, so we can add another one and keep adding like this. So we are gonna create a very long chain of hydrocarbon, so called polyethene. Why polyethene? Because the repeated unit is the ethene one. So this N, it means or refer to the number in which this kind of polymerization or this kind of addition reaction could be repeated. Is it clear here, guys? Guys, is it clear?
Yes, yes.
Okay, so like
Yes,
this
yes.
here, guys, or that's represent the addition polymers, okay, or create making the ethene. Actually, ethene considered to be, or polyethene, which is the result of the addition polymerization, is considered to be a raw material that could be made of different compounds in our daily life. That means we could reform this polyethylene or make this polyethylene involved with other substances to make, okay, different compounds that we deal with our life, because polyethylene actually considered to be the raw material of making different types of plastic, depend on how many, okay, repeated times of that in polyethylene. That means this N in polyethylene could be 15, 20, 30,000, 100. So as the number of ethene units repeated increases, that make its high density and become somehow more rigid and solid and so on. So like this, we have the high density polyethylene, for example. So this high density polyethylene is a linear polymer. That means just one, okay, line of polyethylene. This one is high density, and it could, okay, be hard. So somehow we could find it in some kind of hard plastic and so on. So like this one, which is used to make the this kind of gallons and something like this, okay, that used to keep certain liquids inside, like oils and so on. Okay, also we could find we have some kind of or low density, okay, polyethylene. That means that this is a polyethylene, but doesn't have this repeated number like the high density polyethylene. That means the N is less than this one. So as you can see, it somehow is less than this and soft, so we could use it in making the poly bags and this kind of bags which we use it in keeping objects and so on. And some of them which is branches, okay, we call this the cross-linked polyethylene. Cross-linked polyethylene, that means we have already two chains of polyethylene that they are linked to each other, okay, that is, can be used to making this kind of plastic which is used in making this kind of whatever these plastic pockets or plastic uh, devices, okay, that we sorry this thing, okay, which we use in our daily life, okay, as you can see, because it's here, this cross polyethylene is very, very strong, so and it's become somehow not that flexible, so it could be used to carry heavy objects or to put heavy things inside. Is it clear here, guys? Guys, any hard question here?
Yes.
Any hard question?
No, no.
Yeah. Okay. So like this, okay, the first kind of polymers, as we said, which is addition polymers, okay, that's the polymer based on, okay, unsaturated hydrocarbon or unsaturated molecule which contain double, okay, bond, or which that contain okay, double or triple bond. But here we have another kind of polymer which is the condensation polymer. So condensation polymer, it's look like the word, or look like the reaction of condensation, which you just explained, that the reaction in which we remove water to make two organic compounds combine to each other or connect to each other. So in that case, we're going to find that the monomers of the condensation polymer, they are going to be organic compounds that contain, okay, different hydroxide or amine group, or maybe carboxyl group, so they are easily to remove water from. Okay, so here, like for example, here as we can find, we have here hexanamide. Okay, so that is a hexane that contain two amine groups, so it's hexane diamine. Two amine groups are found here. Okay, and here you find that adipic acid. Why? Okay, because we have two acidic group, two carboxyl group. Okay, so they must be di, because we need to have two amine groups in the two ends and 2 hydroxide groups at the 2 ends to allow adding new, okay, substance to this end, because if just has one carboxyl at what end only, so it will make just reaction for one time and cannot be repeated. So in that case, we cannot create a polymer. For polymer, we need to create a long chain of this compound. So what would happen in this case, as you can see, as usual, in a condensation reaction, the OH of the carboxyl group will be lost with the hydrogen of the amine group, and they are going to attach to each other, creating this kind of tight bond between them and removing water molecule. This process can be repeated many times because we still here have a free hydroxide group, carboxyl group, and here also we still have a free amine group which can attach with a next, okay, acid, and this one can attach with the next amine, and keep doing like this until we create a big, okay, condensation polymer. So do you know now what the difference between condensation polymer and addition polymer, guys? Guys, the difference clear for you, or you still confused between them? Guys, so your silence means it's clear. Okay, so this kind of polymerization which is going to produce, okay, which is known as a common K compound, which is called nylon, okay. So the nylon, somehow you may hear this word, okay, it's considered to be a synthetic fibers, okay. We use it as a kind of fabric for making some materials, or this fabric can use it for many purposes, some in the clothes, some in curtains, and so on, okay, cover sheets and something like this. So we have a lot of uses, okay, for this. Also, it's involved in making some kinds of elastic material and so on. So here, like this, okay, we could find there are multi uses, okay, or there are many purposes that polymers can use for. So here, guys, okay, any hard question regarding to this part? Okay, so like this, okay, we end this section. Okay, suppose you are gonna study very well, okay, and then answer the section review, send your homework through the SMS mail. And like this, we end our material. The material which will be included in the exam will be chapter 18, okay, the first 2 sections, and chapter 22, the entire chapter, the 4 sections. This your material will be included in the exam. Suppose that you are gonna study them very well. Okay, starting from the next week, we're gonna keep revising about each section, okay, till that time of the exam. So suppose you're gonna study your lessons very well, and if you have any question or something is not clear or any part that you cannot understand, get the chance to ask, or just use the remaining time to be sure that everything is clear for you, and then just not skip any part without understanding or asking about it. Any question before we end our meeting, guys? Any question, guys?
Thank you.
Thank you, guys. Goodbye.